This project's goal was a simulation of natural selection using a neural network, also known as an AI. We used Unity to make a visual representation of the simulation. We were very interested in how an AI works and how it's able to make such complex decisions in many different scenarios. We found this project as the perfect opportunity to explore how they worked and decided to create an AI and utilize it for a simulation of evolution. This project was made by Alan Mikhailov, Dev Shroff, and me, Reet Sinha. Alan made the AI the sheep use for decision making and the initial training system so the AI is able to temporarily survive in the new environment. Dev made the 3D CAD models needed for the visual representation and researched information on sheep needed for this project. I created the simulation system that uses the AI made by Alan and the UI or user interface system to help users to play and interpret what's happening in the simulation. The first thing you see when you open the game for the first time is the training UI. When the training is done, the neural network is data saved to your computer so you don't have to go through this process again if you reopen the game. This part takes around 3 minutes because it's being trained in a controlled environment where millions of calculations are done every second to slowly improve it. The UI helps you understand which test the AI is going through and which one takes longer. There are 4 tests it has to pass, each taking longer for the AI to master, except the 4th one because it's fairly simple for the AI to accomplish. The simulation is a turn-based system split up into a front end and a back end. In each turn, the sheep's AI makes a decision on what to do for each turn. You can choose from 500 to 10,000 turns to generate. During this loading bar, all the simulation logic and AI is run, and the data needed for a visual representation is saved into an array, which I then play back in the front end. In the front end, I use the sheep and grass models designed by Dev to make a visual representation of the data created in the back end. The 3D CAD models include decorations like the barn, landscape, and trees, as well as practical models like the grass patches and the sheep models. The box in the top right holds information about a specific turn that tracks information like the current turn or the number of sheep alive in a current turn. You can go to a different turn, which is in range of the number of turns specified in the beginning, to fast forward turns or go back to a specific turn to analyze. You can press Generate again to start a new simulation. The Train Again button lets you train the AI again if the sheep continually die out. Many CAD models were made for this project, including the landscape, trees, fences, lily pads, pond, sheep, and a barn. These models were made from various CAD softwares, including Inventor, Blender, and the inbuilt CAD software of Unity. This project helped us discover some amusing behaviors of the AI. For example, at around turn 20, many sheep died due to not being able to eat or drink. The sheep also seemed to clump around certain areas, which made it hard for the sheep at the center to move or perform any tasks. We weren't able to make it as scientifically accurate as we would have liked it since we had to cut corners for efficiency. While we were able to make the AI reproduce very well, the limitations of our map systems made it hard for the sheep to perform any other tasks. We weren't able to fix these shortcomings in the time frame given, but the experience definitely helped us learn a great deal about working in any sort of large-scale project. This includes the technical knowledge and skills we acquired from scripting the intricate systems of this project. We hope to improve on this project later and use the AI for tasks like voice recognition. The links for our GitHub and documentation are in the description below. We also added an in-depth report in the description since we cannot completely cover this project in a short video.